Hey guys, this looks like a fun one. It says the equilateral triangle sits in the center of the semicircle, and it wants to know what is the area of the square. If you want to try this one on your own, pause it right now, because I'm going to solve it in 3, 2, 1. We're trying to find the area of this orange square. Let's label the sides of the square S, and the area will be equal to S squared. Next, they're giving us the diameter of the semicircle is equal to 6. That means that the radius would be equal to 3. So if we connect the center of the semicircle to this corner of the square, that would also be equal to 3. And from here, let's finish up this right triangle. This side of our triangle will be equal to S, and the base, we don't know yet, let's call it X. And now let's solve for X. In the given equilateral triangle, the X is this portion right here. It's half of the base. Let's take this radius and rotate it over here. That means that the height of this equilateral triangle is equal to 3. And if we connect this vertex to this vertex, we have another right triangle. The hypotenuse of our new right triangle is the same as a side of our equilateral triangle. And since x is half the distance, the whole distance would be 2x. And now we have 3 sides of a right triangle. Let's do Pythagorean theorem. It'll be x squared plus 3 squared is equal to the quantity 2x squared. 3 squared is equal to 9, and this exponent will distribute to both of these to give us 2 squared x squared. And 2 squared is equal to 4. Next, let's subtract x squared from both sides. On the left-hand side, these will cancel each other out. And on the right-hand side, 4x squared minus x squared is 3x squared. Next, we can divide both sides by 3. On the left-hand side, 9 divided by 3 is equal to 3. And on the right-hand side, these two 3's will cancel each other out. So we're left with x squared is equal to 3. Next, let's square root both sides. On the left-hand side, the square root and the square will cancel each other out. And now we've solved for x. X is equal to the square root of 3. And that is what we were trying to do up here. In the place of this x, let's plug in root 3. And now let's take this radius and bring it back over here. And we now have another right triangle. Let's do Pythagorean theorem. It'll be root 3 squared plus s squared is equal to 3 squared. Over here, the square root and the square will cancel each other out. And 3 squared is equal to 9. After we subtract 3 from both sides, we end up with s squared is equal to 9 minus 3, which is 6. And s squared is what we were looking for. So in the place of this s squared, let's plug in 6. This is the area of the orange square. Let's give it a label of units squared and put a box around it. How exciting. And this is the puzzle for day 8. When I place 2, 3, 4, 5 triangles like this, what's the overlapping area? Can't wait to see tomorrow's video. How exciting.